We will now use the theory that we have learned to do partial questions of PET scan. But before we do that, we have to know what we need to remember for this chapter. The theory that you need to know is given here. You have to understand that a tracer is a substance containing a radioactive nucleus that can be introduced into the body and is then absorbed by the tissue under investigation. You need to know this is a definition for tracer. We call that the tracer decays to emit a positron, which will annihilate when it meets an electron in the tissue, producing a pair of gamma ray photons traveling in opposite direction. Then number 3, understand that the photons from the annihilation event will then travel outside the body and can be detected by detectors. An image of the tracer concentration in the tissue can be produced by processing the arrival times of the gamma photons. Then you need to know the formula and the calculation you need to remember. There are two formulas you need to use here. The first formula is use E equals mc squared to calculate the energy released in the annihilation process. Then number 5, use the energy E of the gamma photons to calculate momentum and the wavelength of the photons. You have to use formula P equals to E over C to calculate the momentum. Or you can use P equals to H over lambda to calculate the momentum. Then the energy can be calculated using this formula, E equals to HF or HC over lambda. This question from February, March 2022, variant 42, paper 11. Question 11. The PET scanning obtained diagnostic information from a person. The information is used to form an image. In part A, PET scanning uses a tracer. Explain what's meant by a tracer. A tracer is a substance containing a radioactive nucleus that is introduced into the body and is absorbed by the tissue under investigation. Part B, PET scanning involves annihilation. Explain what is annihilation. Annihilation is the reaction that occurs when the particle interacts with its antiparticle and mass is converted to energy using the formula E equals mc squared. Then in part 2, state the names of the particle involved in the annihilation process. The particle involved are the electrons and the positron. In C part 1, calculate the total energy released in one annihilation event in part B. Use the formula EMC squared. This is the total mass of the positron and the electron. 9.11 is the mass of an electron. 9.11 is also the mass of the positron. And then this is a speed of light, 3 times 10 power 8 squared. This will give 1.64 times 10 minus 13 joule. Then you calculate the wavelength for each gamma photon release. We use energy equals to HF or energy equals to HC over lambda. Lambda equals to HC over energy. So your lambda equals to 6.63 times 10 minus 34, which is the Planck constant. 3 times 10 power 8 is the value for C, divided by half of the value calculated in C part 1. This will give you 2.43 times 10 to the power of minus 12 meter. In part D, explain how the gamma photons are used to produce an image. The two gamma photons travel in opposite direction. The gamma photons are detected outside the body by circular detectors. The arrival time of the photons at the detector is processed, and the exact position and the metabolic activity of the image are displayed.